Here we're going to find out how to use the graphing calculator to find the linearized power regression model. I've got my data in my list, L1 and L2. I have my x values in L1 and my y values in L2. The x values are the elevation, the y values are the pressure. I move my cursor over to L3. I'm going to take the log of the y values, so that's the log of L1. Move my cursor over to L4. Make sure the cursor is at the very top of the list. We'll take the log of the y values, which are in L2. And we'll quit, and then we'll go to Stat, Calc, number 4. And our x list is the log of the x values. Those are in L3. The y list is the log of the y values. They're in L4. I'm going to move my cursor down to store PwrReg. We'll hit vars, yvars, function y1, and we'll calculate. In this case, the r value is the strength of the linear relationship between log x and log y. R squared is the percent of variability in the log of y that is explained by variability in the log of x. Let's use our equation to predict. Remember, it's stored in y1. Also remember that in the linearized power model, we don't put x into the equation. We put the log of x. So let's take, for example, the log of 160 meters. And we hit enter. So our output is the log of y. So we put the log of x in, the output is log of y. If we want the predicted y value, we have to unlog this. So we go second log to get 10 to the power, and then we type in the value that we got when we used our regression equation. When we unlog it, we get 100.64. That's the predicted pressure at 160 meters.